This video will show you the life cycle of a star, one of that of an average star, and another life cycle of a massive star. These are the educational standards that will be met from watching this video. The first stage of an average star are nebula. These are large particles of air and gas that are combusted to make a star. Nebula can take all shapes and sizes and often look like everyday things. Shown here is the famous Seahorse Nebula. Right now it consists of particles of dust and gases, and soon will combust and be a star. When we think of an average star, we think of a small light in the night sky. In reality, after the nebula phase, average stars take shapes of the size of our sun. After an average star consumes all of its fuel, helium is dumped into the core, as shown here in blue, with a hydrogen burning shell shown in red. It gets its red massive shape from the expanded cool hydrogen-rich outer envelope and the increased radiation pressure. After the red giant comes a planetary nebula. Rather than the first nebula with no defined shape and size, this has a more spherical look like a regular star. The last stage of an average star is what you would see in the sky at night. It is very, very dense. Although it has the volume of the Earth, it will be more dense than the Sun. The next life cycle is that of a massive star. The nebula stage is first, just like the average star. Then a couple different stages come, then giant, then supergiant, and then when the star explodes into a supernova, it produces either a black hole, a neutron star, or the supernova remnant gets recycled and starts another nebula to restart the process. Here is just another form of a nebula. There is no definite shape, size, or color, but they all lead to the same thing. Most may not recognize this nebula at first, but it is the second most famous nebula to the Seahorse Nebula. It is known as the Firefox Nebula, and most of you may recognize it from the internet browser on a computer. The second stage of a massive star is a protostar. This is just like a nebula, except it has an energy force that drives things to the middle to form a star. The next step is the main sequence. This is the link between a nebula and a giant star. Again, just like the average star, the red giant forms its shape by sucking helium to the middle, burning hydrogen at the shell, and expanding the cool hydrogen-rich outer envelope. It's hard for people to understand how big a supergiant star is. The Earth is not even seen on this scale. Jupiter is just a pixel next to the Sun, then Sirius, then Pollux, and then the supergiant star. The explosion of a massive star is known as a supernova. The power exerted in a supernova is incomprehensible. As you can see here, this is a before and after photo. Before here, the stars all look the same. In 1987, they captured the first supernova on camera, and it lit up the sky like the 4th of July. One of three things can happen after a supernova explosion. The first is that the particles will recycle into the atmosphere and begin a new nebula eventually, and restart the process. The second, seen here, is a neutron star. This is the particles remaining after the explosion, and the light is burning off as energy. The third and final product of a supernova explosion is a black hole. Once you have crossed the horizon of a black hole, it's impossible to escape. You have then passed the point of no return. This concludes the lesson plan on the life cycle of stars. I've shown you the life cycle of average stars and massive stars. Although average stars can be the size of our sun, or maybe that a little bit bigger, massive stars are almost incomprehensible. I hope you have learned a little bit more about what stars are and where they come from and what they really mean in our galaxy.